So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 309, and in this video we continue with our reference initialization. This time we are in the section indirect binding, and again I skip here the reading. You should read that, and I explain here a little bit the examples. So let's start here. First of all, we make again an object, again a reference object. This time we use string, just the string type. And you can see there is nothing new. We already know what this is. It's a const L value reference and just a string assignment. All right, here, well, when we watch this one, again, a const, this time a primitive type, L value reference, again, just an object. And here is something strange. You say, wait a minute, this is a double. This is not a double. And remember what I told you, what happens here is, the compiler can make an implicit conversion behind the scene, implicit all time behind the scene, which means the compiler say, wait a minute, this is a 2, you want a double, okay, I converted behind the scene this 2 to a 2.0, and then I will assign it. And we already learned you can assign to a L value reference only when you have a const here, because the const says you can bind to temporary value and the lifetime is extended in the scope, in the local scope. Okay, let's go on. What we have here, we just create another variable, this time a normal variable with an int. We assign it the number 2, and now we are using the variable name here as our initializer, and we want a double R value reference. Again, you see this double ampersand R value reference. Careful, it has a name. The whole expression is an L value. But what is here the problem? So the problem here is this one is an R value reference. What we learned about R value reference? You can't bind it to an L value, but this I3 here on top is an L value. So why we can't do this one? And the answer is, I hope you can see it's a little bit tricky, but I hope you figured it out. The I3 here has the type int. We have here double. The compiler says, okay, I can't bind you here, but this one has anyway not the right type. So the compiler will here at this place convert this one to a double, and if it's doing so, this value, which is now then 2.0, it will become temporary. Temporary means I can bind it to a R value reference. That's here the tricky part, and this kind can happen in code also. So you have all time to think about this implicit conversion, and that's why, yeah, these implicit conversions are tricky. And you have to think about it a little bit more. Again, here are lifetime and temporary. Here, this part I skip a little bit, yeah, because it's very important, but that would take a lot of time. And my goal is go back to L values, which we talked, also to the value categories, and make these examples. So I skip here the reading again, but read this through and click here a little bit to understand them a little bit more. I jump again to the examples, and here is again a very special case, and you can see this comes in C++20. So you need a new IDE. So if you are using, like me, is still the old IDE, Visual Studio 2019, this will probably not work. And what is here? What we have here? Again, we make a struct. We have a R value reference member, R, and here we have two kind of initializer. One kind is list initialization. We can see it has curly braces. It's a list initializer, and this has round brackets. It's direct initializer. And the problem is here now, you can see something. This one here, it says, okay, you are allowed to do that. And here it says it is okay, that the syntax looks okay, but dangling reference. What is the meaning of that? Let's see this. So what happens here is it goes in to the struct, it binds to R, and you can use now this value A1 with you can use it in the scope where it was defined. Again, this lifetime scope. Let's say you have here curly braces and here curly braces. Here it is defined, so you can use A1 till this curly brace is here. So in the local scope, after you go out, you can't anymore. Here you have a dangling reference. What was dangling reference again? That dangling reference is something you have here. For example, 7 goes in, so it creates this struct. It initializes R with 7, okay. But the problem here is this one here is destroyed after it leaves this scope here. So the lifetime here is not extended, which means this one here will be not here anymore later. So you will have a problem. And yeah, again, I continue, read this again online in good C++ or in online documentation to understand this thing here a little bit more in detail. Again, on top, read a little bit here, lifetime and temporary objects like things. If it's too complicated, no worry, we will get better. And we jump now to the last section with the big example section here. It's a little bit long, but let's do it fast. So we start here again with a struct S. We create a member variable. We create here a pair. We have not talked about a pair, but in the end a pair is just something like an int. The only difference is an integer like this one variable can only hold one value. A pair like this one can hold two values. But that's not so important. Important is more the syntax here. What I mean with that, we have again a const. We have this one is the type. This one is our reference symbol, which indicates this one is an L value constant. Okay, so far, okay. Let's continue. We have here a function foo. We have here parameter int. Again, we have here what? No name. What means that? Probably that this parameter is not used here in the body, or it has different purposes, but most time not for use cases. So when you see any parameter with no name, the parameter is not used, but perhaps you redefine this function in the future and then you will give it a name and then use it in the code. Who knows? Okay, we continue here. We just create a struct which is empty in this case. Here we use again inheritance, which we talked already. We create a struct B, we inherit this one. What kind of inheritance? It's a struct, so this one will a public inheritance. Then you have to apply the public rules, but A has anyway nothing, so no worry about that. And here we create again int, and here we have our operator, what we already talked about it. And you can see this operator is will return n, and we can convert it. All right, that's nice. And then we have here what we have here. We have here something like a function which has a return type of b, and type of b. It's also the return type of b, but here, don't mix this one. Here we create a temporary instance of b, and we are returning this one here. Okay, I think so far it's also clear. And then we have this line here which says an error. So the question is now, why is this an error here? Why we have an error? Let's initialize. Let's read it. So it says here we have a L value reference. Okay. And then it says here no initializer. Yes, we learned this. I told you if you make an L value reference, you need all time an object, because then all time on creation we need an object here. Okay, this arrow makes also sense, and we know it. This word extern we have not defined, but interesting is now here. Look this syntax here and look this syntax. It's exactly the same, but the difference is Okay, that works. Careful about this one. We will learn this one. Extern means anywhere in your code later, perhaps you have other files, this one, or in the same file but anywhere else, this one is defined, which means it has here an initializer. Here it says it has not. It has here an initializer, and the compiler will search this, and that's why it says okay here. It's a special case, but we can skip that. Let's go here in our main and call all this kind of stuff. Let's start here with the first part. It says L values. Okay, this one we know, this is an L value expression. Why? It has a name. Careful, when I say L value expression, I mean not this part. This part is a PR value because it is just a temporary value which is created here and we have no access. Okay, let's go to the next part and let's read this one. Perhaps it says here L value reference to the object N. We have learned this already, right? We have an L value, we have the name, we have created an N, we have an assignment. Perfect. This is what we know. The only new thing is we call this one L value reference now, because we distinguish that with an R value reference now, which has 2 ampersands. Okay, let's go to the next part. What we have here, reference can be more const volatiles qualified. Let's see what this means. It says here we have a const. Again, this const is here special. All time when you see a const with a reference, think about 2 scenarios. One scenario is it can bind to an L value and that's very important, to a temporary value now too, because this const has this lifetime extension. And let's get into it. Okay, we have here indeed an L value reference, which means let's see what we have here. This is the name. Again, what is that one here? That can be irritating a little bit, because what is that here? There's round brackets here with that. Careful. The answer is not a function. If you set a function, it is a direct initialization. And that's why I said these round brackets are a little bit confusing. But here they use direct initialization, which means, let's see what N is. N is there, and we can bind this one here. And yeah, I think that's okay. And then we go to the next line. So again, the CV here stands for const or volatile, and you can see we have here C for const, V for volatile. Again, this volatile you see not that much often is a compiler instruction, which means you as a programmer say, I don't want that you optimize, that I don't want compiler that you optimize this line. Keep it, because if there is not volatile like this one, behind the scene the compiler can optimize it so it moves faster, smoother, more secure, or whatever the rules are for the optimization. In this line on the other side, the compiler should not optimize it. You want not optimize it because this one yeah, you have special needs for it or something like that. That's why this word volatile. All right, but the same thing here can be used. It's the same thing like here, just another yeah, const volatile qualifier like that one. Let's go here on. What we have here is just again L value reference, and what we learned, we need an object. Do we have here an object R1? And this is also interesting. We can use other references here, because I said you need an object. In this example you have an object. In this example you have another L value reference, so you can use that one, because this one goes here and this one goes here. With other words, this one will be here later, but it is not direct, it is indirect, right? Because you make here a step between till you go to this part here. But okay, that's okay. L value reference to an object N. Let's see what happens here. Again, something wrong. It says here error less const volatile qualified. Let's see. It says here, okay, L value reference, bad name, and CR. What is CR again? Let's read this. CR is this one here. And again, that was our direct initialization. What is the problem here? The const, they are both L values references here and here. The problem is here is const, this one is not const. Why is this a problem, by the way? The problem is you as a programmer, when you want something const, means you should not modify that. And here, if you assign now this one to this one and this one is not const, which means this one tells the compiler I am allowed to modify this one here, and that's why they are clashing. Okay, so far still easy, I think. Let's go a little bit further and see what happens here. So again, we have our CR again, this line. This is our argument for what? This is a special cast. This is a const cast. What is a const cast? Again, that was one of this, not the static cast. A const cast is special because you can cast this const away. Why is this special? Because const is normally not allowed to cast away. If something is const, you should keep it const because a programmer has defined it const for a purpose. And that's why this cast here, this const cast, is treated special, and you should only make it if you know what you do. And important here is again, this cast is what? Interesting, this cast, after you cast this one here, you cast this one away. And then you can assign it, because this one is now the same thing here, because here you have const, that was here the problem. Here the const is gone because of this cast, and now you can assign this one to here. All right, I think you should still watch this one a little bit more in detail. Yeah, if you don't know what this was. Anyway, let's continue a little bit here further. It says here L value reference to function. Okay, what we this one we skip. We have, I think we have not talked about this one. We have not talked about pointers to function and reference to function, and here we have a reference function. We have not talked about the syntax here. That's why I skipped these two examples here. Let's go here and see what we have here. Here we create a B, which means just a B object. Here is our B struct, and I create a B object. Okay, and here it's what we do here. Again, we have here L value reference, and we have an object. We can reference it, and this one is referring to this B. All right, so far all fine. I think that the only difference was oops, I made almost a mistake. Oh, let's say not mistake. I forgot to mention here something. Here the type is A, but we have here B. What happens here? Again, we watch this. If you are not certain like me, then you go up and watch this, and you see B inherits from A, which means I'm allowed to do this because this is a child and A is the parent, and we know we can assign to a parent, right? That was this, and that's why it calls here reference to base subobject. And then we have to still be careful about this kind of stuff, because think about object slicing, about inheritance when you do something like that, because this is the parent, and yeah, you have to be careful about this one. And here what we have here, again L value, again here converted ref, okay, and B again. So similar to this one, the difference here is again we have a B, but this time look this type here, it is int. So what happens here? I mean, B to A is okay because inheritance. At this line I can't see it. Let's watch it. It says in B, what we have here, there is a conversion operator, okay, which means I can indeed assign to B a value. I mean, I can, other way around, sorry, let's go there. What was there again? Where was it? Here. Here, B is of B. And now I want to convert this B type here on the right side to a int. Can I do this? Yes, because of this conversion operator here. it will return the n here, which is assigned here in B when it was created, and it will return this one here at this part here. That's why this one is allowed. And yeah, and okay, I hope you see this. If not, watch again this conversion operator here again, how this works, and then you should see this. And again, reference for a result of a conversion, yes. And here we jump now to the next section. That was the L values, now R values. And here the first example is an error. We can see cannot bind to L value ref to R value. So that was what I told you. You have an L value reference, and here you can't bind it to a temporary. But what was the trick again to bind it to a temporary when you have something like that? It is shown in the next line. You add a const here in front and you could bind this one, and exactly they are doing this here in the next line. You can see we have here an L value reference like this one. Here is just a bad name, and here they have cref, and this one is all the same, right? The only difference is const, and I said if you add here the const, you can bind it and extend the lifetime, and they are doing this. And why they are doing this? Because you have here the two options, and look, the next one is the same thing like this one here, but this time they are using the R value reference. And what was here the difference now? I mean, we have now two versions, what we can do. But what is the real difference here? Or let's say the most important difference here. The word const. Why? Because this value you can't change anymore. You are not allowed to modify. On the other side here, if you have a binding like this one, there is no const in front or something. Means I can change this one. All right. Let's go here a little bit further to the next example. Here, again, it starts with const. You should not modify it. And then L value expression, and then here is our variable name, and here we have bar. What is bar? We have to watch this. Here is the function. What makes bar? Bar is creating, first of all, it's creating here an instance of B. It is returning a B, and what kind of value we have here? Do you remember this one here, the value category, when I call it, not here? So I call it here, so the bar, you can see this one is a call. And what kind of value category we have here? Remember, there are more or less different kind of versions, but one with an ampersand was what? Ampersand was L value. What is this? This one is an R value. The question is now, wait a minute, why is this one R value? The answer is you have to read this. It creates a temporary value here, but it says here also it is creating reference to a subobject of B temporary, because this one is here returned. Let me show you this one. This one is creating here instance. The instance here created is returned here. Yeah, it's more copied here, and then what we have here is so a temporary value from here, you copy it just here, so a temporary copy, and here we have this one here, that's why it's temporary. And yeah, and again, we know if we have something a temporary, we need a const if you are using L value reference. But if you want not to use a L value reference like here, if you are using R value reference, you don't need this const and can write it here. So you can see these two lines are again the same like these two lines here, more or less. The only difference was now, the big difference was now this, they are using a function here call. Okay, let's go here a little bit further. Let's see what we have here. Here we have an R value reference. This is this part. Again, the whole expression is an L value because this one is unnamed. I say this all time because if you are calling this one in a function parameter, it will bind to an L value reference. So don't confuse this one. But we are interested now in this R value because what they are doing here is, sorry, they make a static cast. We talked about this one. It's converting something, an n. What was n? N was this one here. Int, the type int. They are just converting this one to the same type here with a static cast. And yeah, why we can't do this, by the way, because we learned an r-value reference here can only bind to what? A temporary. Is this a temporary value here? And which one actually? Because this kind of temporary value we had already in one of the other videos. It is an x value actually. So it's a temporary value because x value and PR value are still R values in the category R values, temporary value. And here we talked about this one is you have to be careful. This is only a x value here on this right side, but we are binding it now to this one, so the whole thing it's no more an x value, which means if you call it again in a function, it will bind to an L value reference. L value reference is something like this, instead binding to an R value reference. Keep this in mind. We had there this one example. Okay, let's see what happens here in the next one. It says an error. Can't bind to an L value. You can see here we have an R value. This time is just a name copy ref, and this time is they are trying to bind it to an L value. This is again a repetition what I told you already. You can't bind it to an L value, which is an object. It must be temporary value, and n is not temporary. N is defined here, and so it's not temporary value, so you can't do this one here. And let's go on. We have now here, I just told you, you can't bind n to a R value reference, right? But they are doing this here on this line. How the hell doing it? Yeah, try to figure this out. It says here bind to an R value temporary with a value 1. But we just had this example here. N is an L value. It exists. It's not a temporary value. It is here. They are indeed using it. And I hope you see it because we had this example before anywhere. Again, when you watch this one, careful. This is a double. What is n? N is a int. And again, what kind of initializer we have here? This equal sign is a copy initializer. And what is the compiler allowed to do with a copy initializer? Yes, an implicit conversion. Implicit conversion means what? It says, oh, you have here an int, but you want a double, so I will convert this n here at this place, here on the right side, to a double, but this double is then a temporary value because it is not saved anywhere. It is just created here, and that's why you can assign it to an R value reference in this case. This one is temporary because the compiler is converting this one to a double at this place. It's not visible implicit conversion. Careful about this implicit conversion, what the compiler is doing. We as a beginner have to learn this. Or if you want to avoid this one, you know you are not using this copy initializer, then you would use this this curly brace initializer here, this list initializer. This would give you an error actually because implicit conversion is not allowed. I hope you remember this one. If not, make a code example and you will see that that's very important. Let's see what we have here. Perhaps I skip here again a part because here comes things which we have again not talked too much, I think. And that's why I skip here the other part. Of course, you can watch the other things here too. But yeah, we have definitely not talked about lambda. And here we have, I think, it's again this pair. This pair, what I said, you can have two ints, or depends here. It's not a pair int pair. It's here an object pair of s. okay, we skipped that. So I hope you understand most of them. If not, don't worry. We will make still more examples, because in my next video I will go back to the value categories and we go all the examples like we did here through, but I make it again a practical example. What I mean with that is you will have, again, pause the video, try to answer as best as you can, and I have the answers there, and we go through not all the examples but many examples I will make. And there is one more thing what I wanted to mention. I don't know it right now, so if you have any questions, like all time, write in the comment section. See you in the next video. Bye, good luck, and have fun.